Hello, I'm Ray. I'm amateur call sign WB6LST and GMRS call sign WRQH312. One of the things that's really popular in the ham community these days is summits on the air and parks on the air. And that's where the hams go into a park or up to a mountaintop and operate from there to see how far and who they can communicate with via radio. Obviously that requires a battery, and there's no shore power typically available up there. The other thing is for GMRS operators is emergency preparedness, or preparedness for when the stuff will hit the fan. And in either case, there's going to be an assumption that there's no local plug-in power that you can operate or recharge from. Well, I discovered a product made by Impulse Electronics called the DC12 MITY GO-BOX. And it's a 12-volt battery. I'll open it up so you can see. It's a 12-volt, 15 amp hour lithium iron phosphate battery. And it has a built-in charger and comes in a really nice rugged case. The advantage of the lithium battery, of course, is there's no liquid to spill, so you can turn it, any which way, carry it in your go bag, and you won't have to worry about problems like lead acid battery would give you. It's got a power pole connector on the side. It's got a 12-volt car and marine type socket rather, and it's got USB ports on it with a digital voltmeter. So it's a pretty cool little package. Let's go inside, take a look at it, and then come back outside and actually try it out. The Impulse Electronics DC12 MITY GO-BOX is a lithium iron phosphate battery that comes in a case, and the battery comes in 4 sizes: 9, 12, 15, or 20 amp hour. The rugged duty outer case has a handle, and the 3 electrical power connector ports are on the side. The first port is made up of 2 power pole type connectors. The yellow and black pair are for connecting a solar panel to the battery, for charging the battery using a solar panel, and the red and black port, or output ports from the battery, to power a radio or any device using the power pole type connector. The advantage of using power pole connectors is that you cannot connect them the wrong way, so that's a big safety feature. The center connector is an automotive type 12-volt socket for a cigarette lighter plug. Most of us are familiar with these sockets in cars. In this case, it's used the same way as a 12-volt power supply to feed equipment with that type of connector for temporary power, like a power inverter, for example. The final connector is a combination of both USB Type A and USB Type C connectors, and a digital voltmeter to check battery voltage. If we open up the case and take a look inside, we'll find the battery. It's a lithium iron phosphate 12-volt, 15 amp hour battery. And we also find a battery charger power supply for it. One end plugs into 110 volts, and the other end plugs into the battery with a connector just like this. If we rotate the case around, we can see down inside the charge controller on the left. And over on the right, we see a 30 amp thermal resistor type fuse. If the load gets too high, the fuse will break the circuit. And when the load problem goes away, the fuse will reset. So packing away the power supply and closing the case back up, let's take a look at the watt meter. This is the watt meter. It's a very nice little unit, compact and easy to use. What we do is we plug it into the power pole connector on the left connector. And you can see the power pole connectors. You can't mess them up. Here we can see the different measurements that the meter is looking at. But because there's no load on the battery, there's going to be no indication of any sort of number other than 0, except for the voltage. So that's an overview of the battery power supply. Let's hook something up to it and see how it works. All right, so we've come back outside to take a look at this box. Now, in my go bag, the battery and the essential components for the system weigh between 8 and 9 pounds, depending on whether or not you have the inverter in there or not, but we'll get to that. So let's just say 8 pounds for argument's sake. We have the battery, and as we saw inside, we have the 3 ports. And I have an Anytone 878 radio. Now, I think the best way to show this box is to break it down into segments. So I'm going to start with a real basic system, basic charging system. This battery requires 12 volts into the cradle, the charging cradle. So 12 volts out of here into here, that's a pretty straightforward and simple thing to do. I'm going to grab a jumper cable that I have, which has a power pole connector on one side and the coaxial type connector on the other. I'm going to plug that into the charging cradle. I'm going to plug the other end into the power pole connector and put the radio in the charger, and it's charging and it's good to go. So this box is now charging this radio. Now, the next thing we're going to look at is if you have another radio that doesn't take 12 volts, something different such as 10 volts, like the Baofeng UV5 Plus R. So let's go take a look at that and how we would charge that. This is the Baofeng UV5R Plus handheld radio. It's a very popular radio, and I'm going to show you a couple of ways that you can either charge it or operate it using the MITY box. The battery requires 10 volts to charge it. If you look at the bottom of the cradle, you can see that there's a sticker on the bottom that says input DC 10 volts. The wall transformer plugs into 110, converts it to 10 volts, and then you plug it into the cradle, and it's feeding at 10 volts. Well, the MITY box is 12 volts, and we can't obviously plug it right in, so we need to go through something in the middle. Well, that would be a power inverter. In this case, it's a 300 watt sine power inverter, and on the one end you have the power pole connectors, and on the other end you have 110 output with some USB ports on the side for charging phones such as iPhone or Android. Over here we have an on-off power switch. It's rated at 300 watts with a peak of 750 watts. So it's more than enough to do what we're talking about doing, charging and operating radios. We're going to plug it into the power pole ports. Let me move it closer so you can see. Hopefully you can see it. So we're plugged in there. We're coming out of 12 volts into the inverter, coming out at 12 volts into the inverter. And then we're going to take the wall transformer and we're going to plug it into one of the sockets, turn on the switch, and if you look carefully, you can see the red light. So it is getting power from the box through the inverter out at 110, and it's converting at the transformer here from 110, converting it down to 10 volts into the cradle, and now I am charging the radio. Now, if I wanted to operate the radio at 12 volts, there is a way to do that. Let me take apart everything, turn that off. All right, there is a sleeve that you can get for the UV5R Plus, and it replaces the battery on the back of the radio. So you take this sleeve, it's got an automotive cigarette lighter plug, and it converts it through the sleeve adapter at the radio. So I'm going to slide that on like that. Now if I plug this into a car lighter, it'll power it, or I will plug it into this plug here, and you will see
frequency mode
that it is powering the radio. So it's coming out of here at 12 volts, running through the automotive plug, through the sleeve, and operating the radio. So that's another way that you can run the Baofeng UV5R Plus radio. So either this way with a sleeve to power it, to operate, or using the power inverter, which Impulse Electronics does sell, and you can pick it up on their website too. The next thing in our go bag is a lithium battery charger. Now, this is a 12 volt system, but if you plug it into an automotive system at 12 volts, it will not come to a full charge. You need one of these lithium battery chargers. It takes 8 volts DC input up to 36 volts DC input and outputs the voltage at 14.6. So anywhere from 8 to 36 volts in, and it will regulate it and come out at exactly 14.6 volts, which is what this lithium battery requires to be charged. So if you want to get a full charge out of it, you need one of these. And the way it works is very simple. You have an input and an output cable here. And what we do is we take the input to the charger from a 12 volt source. So let's say we do have a car battery. Well, we can use this car plug, power plug, 12 volt car power plug, put it onto this unit here. So now we're feeding into this charging unit at 12 volts. Remember, it'll take 8 to 36 volts, so 12 is fine. And then you take the other end and you plug it into, I'll move this closer. You plug this into the red and black port. Now this port is bidirectional, so it can output and input. And in this particular case, we're using it as an input to the battery. So what we have at this point is we're going to plug this into a cigarette lighter plug in the car. It's going to go through the charging unit here and output at 14.6 volts to charge the lithium battery in here. Now on the side of this, you can see it has 2 amp, 4 amp, and 8 amp. And we're going to run it at 4 amp because this is a 15 amp hour battery, and they require it, ideally it's the 4 amp setting for that according to the instructions. So if you want to charge this in the field from a car or from any voltage between 8 and 36 volts, get one of these charging units. But if you're in a situation where you can't connect to a 12 volt system like this, what you can do is remove it and attach these alligator clips. And again, the same thing applies. You can hook them to a terminal of a car battery or a boat battery or whatever, 8 to 36 volts DC, clamp into them, and the charger will output again at 14.6 volts DC into the lithium battery. So I highly recommend getting one of these if you're into preparedness. You'll get the alligator clips and the car socket, the cigarette lighter plug socket. It's all connected using the power pole connectors. It's a great system, and I highly recommend you think about getting one. All right, I've saved the fun part for the end, and that is charging with solar. You're in the backcountry, you have no vehicle, you have no shore power, you have no power basically. But you do have the sun, and that's where the solar panel comes in. In my go bag, I have a 40-watt foldable solar panel. And the way this works is very simple. In here, in the back, is a little cable, and on the end of the cable is the power pole with the yellow and black connector. Now if you remember on the box, the yellow and black here is for the solar charging. There's a solar charge controller in the box, so you can plug the solar panel directly in and it will regulate the charging circuit. So we open this up and we are now almost ready to charge. Just plug it in and go. So we plug it into the solar charging circuit, yellow to yellow and black to black, like that. And now we have solar charging. The solar panel is feeding the charging circuit in the box and charging the lithium iron phosphate battery. So this will work, and this works very, very well. But if you really want to maximize performance, you'll want to attach a watt meter. I'll dig it out of the bag here in a moment, and we'll take a look at it. The last item in my go bag is a power meter, and I use that for aligning the solar panel to get the maximum energy from the sun. And the way you do that is by attaching, one side says load, one side says source. There's source and there's load. So in this particular case, the source is the solar panel and the load is going to be the battery because we're charging the battery. So I'm going to put the load side of the meter into the solar port of the box, which I'm doing here. Hopefully you can see it. And the the source part of it is going to be the solar panel. And again, matching up black to black. So the source is the solar panel, the load is the battery, the energy is coming down the wire through the meter into the battery, and this will give us a display of all sorts of information like the watts and the voltage and information like that. So it's really good to have, but you can this way aim the panel for maximum energy if you really want to get the maximum performance out of the solar panel. Now this meter is also good for using on when you're charging something, or like we were doing the Anytone radio in the cradle, for instance. What you do is take the meter and you get, the source in this case would be the battery and the load would be the radio charger. So the source would go into the output of the battery because again we're taking the energy out of the battery and we're going to run it into the cradle. If I can get it, there we go. And my jumper cable is here, like that. Let me move things over so you can see it. There we go. All right, so I've got the little demonstration jumper cable going into the back of the cradle. I've got these guys connected using the power pole connector. So now the energy is coming out of here, flowing through the meter. It'll give me information, wattage, voltage, etc. And it goes into here. So this is a handy little instrument to have for data. Right now it's telling me it's got, well, it's nice and happy is what it's telling me. I won't read all the data. Not necessary to have this meter, but if you want to do it right and have all the toys and bells and whistles, definitely worth getting. Well, that just about wraps it up, but I want to put everything back in the bag just to show you that my Go bag has everything that we talked about self-contained here. The MITY Go-BOX goes in there. My Baofeng radio goes in here. The power analyzer goes into there. My lithium battery charger and power inverter go there. Solar panel into there, and my cradle for my Anytone, and I still have room left over, as you probably can see. So it all fits very nicely into the Go bag. If you found this helpful and informative, please like, share, subscribe, and leave a comment down below. I'd love to get some feedback from you. Be sure to check the description. There's going to be some information in there that's probably of interest and value to you, so take a look in the description field down below. And until next time, I'm WB6LST 73.